Let's talk about Jank. In this case, application Jank. So, say you are developing a web app, as I am here. And this one is using Next.js, and it represents kind of like how long you have to wait at the Department of Motor Vehicles. You'll wait. So we've got this clock up here, and then we've got these users who each are in a different position in a queue. They're each waiting. They have some wait time they've been given. Now, this application is backed by a convex deployment. Convex is a reactive database, and backend is a service that stores your data and sends it to all your apps in a way that's pretty cool. So because it is reactive, we can come in here. I think right now, Greta, let's see. Greta's right around 6:40 is the pickup time. If we make Greta wait 2 more minutes, we should see that minute hand jump forward just a little bit, and it does. So reactive database at work. One more change. Let's take Karen, and Karen is now, ta-da, Carrie. Good. Everything working. So everything hooked up, database backed system, nice iteration times, everything's great, right? Not quite. As you might see here, as we switch between these different users in this users table, there is Jank. It redraws the whole thing. And because we're using React router here, this stuff is all going into the history, browser history. So if we hit back and forward, you can see kind of infuriatingly, we are redrawing the page when we hit back, and it feels like that just shouldn't happen, right? We just loaded that value. Why aren't we showing it again right away? So we want to fix the jank. So what are we going to do about that? Well, I'm guessing that you might be thinking some kind of cache, right? And yeah, the answer is yeah, it is some kind of cache. But this one might be a little different than you're used to. This one has a little trick up its sleeve that's pretty interesting and reveals something kind of specific about convex that many users find useful. Let's dive in and take a look at how we achieve it here. So what I'm going to do is I'm going to make exactly 2 changes to my app here. The first thing I'm going to do is I'm going to go into my layout where I've got my providers in Next.js, and I'm going to add a convex query cache provider. And by doing that, I'm making sure there's a context in my React app that has a cache in it so that all of my components have access to this cache when they are issuing convex queries. Then inside of the page itself, I've got these use query calls. This is the time from the DMV. This is the list of the users. And then if we're on a page with a user, I load that user, including using the URL parameters, right? So I've got these use queries. These are being automatically updated because of the subscriptions. But instead of using the standard one from Convex React, I'm just going to replace these with the use query from the caching library, the corresponding caching library that also had that client provider. And that's it. 2 changes, and everything automatically deploys. And when I come over here, take a look at my app, after my initial load, yeah, there we go. So we're just reusing the values. The cache is working. And if I go back, yep, everything's good. I can hit the back button and everything reloads instantly. So the jank is gone. We did it. Good job. So you might be saying to yourself, yeah, I know I've seen this before. Like lots of the data loading request libraries have a cache in them. This isn't that big of a deal. And you're right. But this one does have something a little different about it that we'll dive into now. So although it seems like this may be just a standard cache, it's actually not caching values. It is caching subscriptions. So, I'm looking at Greta's time, and if I go and change it, like right now, I think it's a 7-minute wait time. Yeah, we changed that. Let's move her back to 5 minutes. Let's be nice. So the reactivity is still working, of course. But what you might be surprised to see is that Greta's back at 6:40. If we go over to Sujay's page here and we update Greta's time in the background, we can move it 2 minutes forward again in the database, and the app, the cached value, will have updated, right? So we have cached these subscriptions to data, and so we're continuing to get these consistent bunches of data when transactions happen pushed back out to our app, even for things that we're not currently rendering. That way, when we use this cache, everything is still consistent. So that's pretty cool. That is kind of the just works sort of experience you would expect, where you don't want to trade off performance for like correctness. You don't want to deal with invalidating caches yourself and things like that. Just to really like maybe bring home though how pervasive this is, let's do one more change to this app. So let's set up a cron job, because in this app, this DMV time is in this other table here I haven't shown you yet. And it's just been sitting here static. So nothing is happening. Everyone's waiting forever. The DMV time is still. And time does move forward. Let's see if we can fix this. So inside of our app, everything in a convex project is just regular old TypeScript, including cron job specifications. I'm going to add a cron job to this crons object that I'm going to call, let's call it update DMV time. And then I'm going to make it happen, let's see, every 3 seconds. And it's going to call a convex mutation, which is how we change data in convex reactive databases, called update time. So update the time every 3 seconds. Convex automatically deploys in the background. We should see this second hand start ticking. There it is. Yep, 3 seconds, tick, 3 seconds, tick. We can even see that on the dashboard here, which is also subscribed to the value. It goes green, and these guys jump, and the cron job is updating the time in the background. Our query that is returning the arrival time for all of our users is based on this time, and then adding the interval here to it. Once again, all queries in convex are also TypeScript, so that looks a little like this. It's just user wait time. We get the user object, we get the time object, and we add them together and return that. So, all right, we got this going. Now watch what happens. So you'll notice the DMV time is ticking forward, and so are the cached values, right? Those subscriptions are continuing to pull forward new values in consistent transactional windows as the background data changes. And so we haven't merely cached a stale value that we can use to re-render, and then we got to go pull and maybe we invalidate, or we've actually just been getting streams of updates pushed to us in the background. And I can use the back and forward buttons and rapidly switch. It's kind of trippy, right? So I'll go forward and backward, and you'll see all of their pickup times change a bit, but the second hand is the same for all of them. It keeps ticking along with the DMV time. So, in summary, we sort of did a little technique here to use this caching library to leverage the fact that these subscriptions are really powerful in convex to cache the subscriptions instead of just the values. And because of that, we're able to have an app that loads very quickly, but doesn't have a lot of the like consistency issues and manual cache invalidation issues you have with a lot of traditional databases and backends. So this is kind of one of the many really powerful techniques that convex opens up, new architectures it enables. If you haven't tried it yet, go to convex.dev and give it a shot. And thanks for watching.